Imagine your Kubernetes cluster accidentally schedules regular workloads on your expensive GPU nodes. Taints and tolerations exist to prevent exactly this kind of disaster. Taints are applied to nodes to repel pods. When you taint a node, you're essentially putting up a barrier that says only certain pods are allowed here. Think of it like a bouncer at a club. By default, no pod can schedule on a tainted node unless it has the right credentials. Tolerations are applied to pods to allow them to schedule on tainted nodes. A pod with a matching toleration can bypass the node's taint and get scheduled there. The toleration is like having the VIP pass that gets you past the bouncer. There are 3 taint effects. NoSchedule prevents new pods from being scheduled on the node. PreferNoSchedule tries to avoid scheduling there, but isn't a hard requirement. NoExecute is the strictest. It prevents new pods and evicts existing pods that don't tolerate the taint. For a pod to tolerate a taint, the key, value, and effect must all match. The node has a taint with these 3 components, and the pod's toleration must specify the same key, value, and effect. You can also use an operator like exists to match any value for a given key. A classic use case is dedicated GPU nodes. You taint GPU nodes with hardware equals GPU and effect NoSchedule. Then only pods that need GPUs add a matching toleration. This ensures your expensive GPU resources are reserved exclusively for machine learning workloads. Taints repel pods from nodes, tolerations allow specific pods through, and together they give you fine-grained control over where your workloads run. Master this pattern and you'll avoid costly scheduling mistakes. Want to get better at answering questions like this? With Interview Mentor, you practice real interview questions out loud. You get personalized feedback and a grade on every answer, and you can track your improvement over time.